Okay, we now focus on this integral here, right? This is a very easy one. The reason is we have a primitive of this function. So in those cases, analyzing this is straightforward. The only tricky point here is that this is a double improper integral. It is improper because the upper limit is infinity, but it's also improper because the lower limit is infinity. And that means that we have to split this integral in two, right? And analyze them separately. And actually, you will see that one of them is convergent and the other one is not, right? But there's something easy that we can do here is that just change of variable. We can change from x to minus t, right? And then after doing the changes, what you have is integral from 0 to infinity, right? And here you have e to t dt, right? There is a minus here from the differential, but also the limits are reversed, so you compensate one with the other. At the end of the day, this is you transform this integral into this one. And you also have this one here, okay? So you can calculate these two integrals separately. As I said, there are primitives here. So first one, this, well, let me focus on this one first. The integral from 0 to c, let's say, e minus x dx. The primitive of this is minus e minus x. So you have to evaluate that at 0 and c. At 0, this is 1, so you have 1 minus e minus c. And obviously, when c goes to infinity, this goes to 1. So this one is a convergent integral, and we already knew that, right? Because we have analyzed this in class, in an exercise. But this one here is another story, because if you want to calculate the primitive of this, well, there is a primitive, no problem with that. The primitive is that. But then there's a difference with respect to that one, in which what we get is this, e to plus c minus 1. When c goes to infinity, right, which is the limit we want to calculate, this, of course, goes to infinity. So this integral here diverges. So the integral we were analyzing diverges.